Good morning. This is Dr. Dell speaking, and on this video I want to talk to you about the calculator that we're going to be using throughout this training. It's called the particular model we're going to use is the Texas Instruments 30XA. It sells for about $10 depending on where you buy it, and it's a marvelous scientific calculator. There are many models on the market, as you no doubt know. This is perhaps my favorite one for a variety of reasons. Now, it does use a battery. It's not solar powered, but I'm told the battery lasts many years, and so that's really not a disadvantage for me, and it has so many features I like that I use it. Now, a calculator is when you're doing mathematics, particularly everyday real-world mathematics, a calculator is virtually an indispensable tool, in my opinion. And so you need to learn how whatever calculator you're using works so that you can use it quickly and efficiently to do the arithmetic that's involved. Many years ago, as you no doubt know, those of you particularly that are older, when we had to do all of our arithmetic with pencil and paper and lookup tables, that consumed a great deal of our time when we were trying to solve math problems. Today it now becomes very easy. Now, like any tool, you need to understand it so that you can use it and not make mistakes. And I'm going to show you some of the basic things that we're going to be doing in this training. I'm not going to show you everything this calculator can do because it has functions beyond what we use in what I call everyday math, but I will show you the things that we're going to be using. First of all, here's the on key up here, and here's the off key. And so I, generally speaking, turn it off before I start using it, turn it on, and it comes up then in a certain state. Now, over on the left, you'll see there's a couple little things there, M1 and M2, and that means that I've stored two pieces of information in the past in two memories. There's actually three memory locations. It also comes up with a little DEG sign, which means that if you do enter some kind of angles, it'll be in degrees unless you change it. And I'll tell you in the trig section how you change that. Now, the keys that you're going to use over and over are the basic arithmetic keys. And the bottom key is the equal key. Whenever you're doing a calculation, you can always calculate it in intermediate value by hitting equal, and that'll show you what you've done to that point in time. There's a plus key for addition, minus for subtraction, an X for times, and a divide key. And down next to the equal key, there's a little key here that will let you change the sign of a number from positive to negative or back again. Then there's some special function keys we'll talk about today. There are some trigonometry keys, sine, cosine, and tangent, which we'll talk about in the section on trig, so we won't talk about that today. And there are some keys down in the lower left corner that are used for fractions. This is a very nice feature of this calculator. Sometimes when you're doing some calculations, you're given dimensions and fractions, and you want to convert them to decimals or vice versa. I'll show you that on a separate video. There's also some keys over here, if you look above, you probably can't see it on here, that lets you convert degrees, minutes and seconds into degrees and decimal. And there's a few other special keys. The little yellow markings above the keys are special functions that you can do by hitting the yellow key first and then hitting the key, and then it will then do what's above, what's ever written above it. And I'll show you that in just a second. So that's an overview. And at the top you have some keys called logarithm and exponentials, and we're not going to go into that either. We'll not need that for what I call everyday math. Now, that's a quick overview. So let's just take a quick look at this thing. Let's start out by taking 1 and divide by 7 and hit the equal sign, and you'll see now that you have a lot of numbers there, 0.142857143. And as we talked about in the section when we discussed real numbers, generally speaking, you don't need that many digits. Most of those digits would be meaningless in a typical practical application. So if you don't want to look at all of them, you can look at however many you want to. And the way you do that is you hit the second key and the decimal point. Above the decimal point it says fix. So you hit the decimal point. Then you hit the number of positions you'd like to see. I'll hit 3, and now that shows us 0.143. It rounds up or down. If I wanted to see 4 decimal places, I'd hit second decimal point 4. Now I'm seeing 4 decimal places. If I hit second decimal point 0, I see no decimal places. It shows a 0. Of course, it isn't 0, but because it was less than 0, it rounds down, it rounds to 0. And if I go back and hit 2 decimal places, I'm back to there. And you always want to be mindful of how you have fixed the decimals, if indeed you've got them fixed, because I sometimes get fooled myself. I'll fix them to 0 on a problem, and I'll forget I've done that, and then when I do a calculation like 1 divided by 7, I get 0. Well, that's not correct, but because I fixed it to 0 places, it doesn't show me. So whenever in doubt, I go and give myself a few decimal places to look at to be sure. So we're going to use the fix key frequently just to make our numbers up here a little more manageable and what we want them to be. Now, having said that, whenever I'm not sure how a calculator works, I put in some numbers that are very easy that I can do in my head to be sure it works right. For example, if I wanted to be sure that was the addition key, I'd say 1 plus 3 equals, and sure enough, I get 4. Now, notice I'm getting 4.000 because I fixed it at 3 decimals. I could fix it again at any number of decimals I wanted to. Let's see. 1 plus 3 equals 4, and then I'll fix it to, say, 2 decimal places. Okay, now, similar for subtraction. 7 minus 5, we know what that'll be. That'll be 2. If I take 5 minus 7, I should get a negative 2, and indeed I do. And if you're not sure what that means, you need to review the training we've done on real numbers already, where we talk about negative numbers. 3 times 5 is 15. 4 divided by 2 is 2. 9 divided by 3 is 3, and so on. So yeah, you can do the calculations with numbers you know, because normally you're going to have more complex numbers, and then it's not easy to do in your head. 12.5 times 3.47 equals 43.38, and indeed, while I could do that with pencil and paper, I could not do that easily in my head, and I don't want to do it with pencil and paper. It's just too time-consuming. Now, one of the things that calculators don't always behave the same on, you want to be sure you understand, is the order in which they do things. For example, let's take the problem 1 plus 2 times 3 and see what do we get. Now, if I don't put any parentheses in, it's implied that the multiplication is stronger than the addition, and this normally then would be interpreted as 1 plus 2 times 3 with parentheses here. However, with this calculator, it doesn't know that, and so it just assumes when I put this in that the parentheses are there, and so if I hit 1 plus 2, then I hit times 3, it gives me 7. So it would put the parentheses in there. Now, look at this. If I hit 1 plus 2 and hit the equal sign, that gives me the intermediate value of 3. Then when I multiply that times 3, I get 9.